Okay, welcome back to Unit 6.3 Kinetics. This is part 2 of 3. Okay, in the last part, part 1, we learned what a reaction mechanism is. And remember that's a sequence of steps known as elementary steps that when they combine together will form the overall or result in the overall balanced equation or overall reaction. During these elementary steps, we oftentimes produce and consume intermediates. And what we also learned in part 1 was how to identify intermediates and also how to identify catalysts. So A is a catalyst because it's not found in the overall reaction, so you don't see A anywhere. And in the mechanism, it's shown as a reactant first and then a product. On the other hand, B and YZ are intermediates because they're first found as they're not found in the overall reaction, and they're first produced as a product and then they're consumed as a reactant. So first in step 1 you see B as a product, and in step 2, the subsequent step, it's a reactant. So now we're going to dive a little bit more deeply into reaction mechanisms, and especially in terms of their relationships to rates. One thing that's important to know that reaction mechanisms cannot be proved, but only disproved or accepted. So what scientists will do is they'll run a bunch of experiments and then use that experimental data to sort of propose a reasonable mechanism. And one thing that they'll look for in the experimental data is evidence for a certain intermediate, and how long that intermediate persists and what forms after that intermediate. So that's how they sort of builds up a profile of the mechanism. And through this data, subsequent scientists will come, or future scientists will come and prove, provide data that supports that mechanism, or provide data that says that mechanism is no longer valid. So that's something to sort of keep in the back of your mind, that's why you'll see a bunch of different mechanisms proposed for a single reaction, because you can't really prove, but only disprove them. All right, criteria for accepting a reaction mechanism. So first of all, if a scientist is going to propose a reaction mechanism, there's 2 things that must be true about that mechanism in order for it to be considered reasonable. First of all, the sum of the elementary steps of that mechanism must equal the overall reaction. And that goes back to using Hess's law. So yeah, that's right. Hess's back. That's right. We use Hess's law a lot in chemistry because it just sort of makes sense. So when you add up the parts of something, it should result in that overall something. The other criteria that is true is the rate law from the mechanism must match the rate law of the reaction. So we'll have to learn how to write rate laws for mechanisms and then prove whether or not those rate laws match. In this video, we're going to focus on basically the first criteria. So let's go back quickly, is that using Hess's law to prove that the sum of the elementary steps overall equal the overall reaction. In part 3, we'll look at how to prove the mechanism from the rate laws. Okay, so sum of elementary reactions must equal the overall reaction. So here we have this reaction. We saw this in part 1, A plus B goes to C. And step 1, 2, and 3 are the elementary steps of the mechanism. So this is the proposed mechanism here. Now, if we add them together, we will find that the sum of these steps will equal the overall reaction. Well, how does that work exactly? You may recall from Hess's law that anything that's found on both sides of the reaction arrow will cancel out. So if something's found as a product and a reactant, it's going to cancel out. And that's true for intermediates, because remember, they're produced first and then they're consumed as reactants. So all the intermediates will cancel out. And then what you're left with should just be reactants and products. And you can see that here. A, B, and C are our reactants and products. So now when we add these together, we have on the reactant side 2 A's, 2 B's, and on the product side 2 C's. So that gives us an overall reaction of 2A plus 2B plus 2 goes to form 2C. Now you may look at this and say, well, that doesn't quite equal the overall reaction. But remember, you can simplify this by factoring out the greatest common factor of 2 from the coefficients. And so once you do that, you get A plus B goes to C. All right, let's look at another example. This was again from part 1. So the overall reaction is above. 2x goes to form y2 plus c. And we're going to add up the steps of this mechanism to prove that it equals the overall reaction. So again, anything that's found in reactant and product side can cancel out. That means that the catalyst A can cancel out because it's found as a reactant and as a product, and the intermediates can cancel out as well. So all of those cancel out, leaving us with, on the reactant side, 2 x's, and on the product side, y2 and 1z. And so when you add them together, you get this overall reaction, which matches the overall reaction that we saw above. Okay, let's look at one more example. So I want you to add up the elementary steps of this mechanism using Hess's law. And what's helpful here, because in the previous ones I've already identified the intermediates and the catalyst, it's helpful to identify those first. So let's first take a moment to sort of review and look for intermediates and catalysts. So remember, if you're looking, this is our first step here. Cl2 was a reactant, so it's not an intermediate. 2Cl is not a reactant or a product, so that's likely an intermediate. And we see it again as a reactant. So first we produced it, and then we see it as a reactant in both steps 2 and 3. So I'm just going to circle those as my intermediate. Now I'm going to look for any other intermediates. CHCl3 is a reactant, so I'm not going to circle that. HCl is a product. CCl3 is not a product, okay? And I find it again on the reactant side of the third step. So first it's a product, then it's a reactant, it's definitely an intermediate. Okay, and CCl4 is a product, so I'm not going to cancel that out. So let's just go ahead and check. Let's see if they cancel out. We have 2 Cl's on the product side and 2 Cl's on the reactant side, so we're going to cancel all those out. And then we have 1 CCl3 on the product side in step 2 and 1 CCl3 on the reactant side in step 3, so we'll cancel that out as well. All right, so now we can go ahead and add them together. On the reactant side, we have Cl2 and CHCl3, nothing else on the reactant side in step 3. And on the product side, we have HCl and CCl4. And so that's our overall reaction, and that matches what we saw above. So when we sum these together, we get the overall reaction. All right, it's your turn to try it now in the CFU. So pause the video now. You're going to use Hess's law to prove whether or not this is an acceptable mechanism based on whether these elementary steps will add up to the overall reaction above. So pause the video now. When you press play again, the answer will be revealed. Okay, so when we add them together, or right before we add them together, we identify some intermediates here. So N and N2O are intermediate. So we're going to just quickly cross those out and sort of see what we have left. We have 2 NOs on the reactant side, and actually that should say 2H2. There's an error there. So there should be a 2 here, 2H2O on the reactant side. On the product side, we have 2 waters and 1 N2. So let me just quickly go ahead and change that so we have that there. There we go. Okay. So that matches our overall reaction. So according to Hess's law, this mechanism is reasonable or is acceptable. All right, that's it for part 2. We're going on now to part 3.